Okay.
Yes. Yeah. So for this session, we'll be having Dr. Rajendra Prasath. He is bestowing his interest in the fields of machine learning, business intelligence, modeling, informational retrieval, basically everything trending in the industry, and inspiring students like us. He has been into teaching with data structures, computing programming, and algorithms. Also, Dr. Prasad has won many achievements in Best Short Paper Award, AIR's 2013, Visiting Fellowship Norway, NTNU, and MHRD Research Fellowship, IIT Kharagpur, ad hoc Trudge Coordinator in FIRE 2011, and many more of such. He has also worked on publishing books on intelligent computer communication and processing, approaching in interconnection networks, intuitive algorithms for rotation about arbitrary axis, and many of such. From span of 2013 till date, he has worked on research and teaching from 2018 in IIIT Sri City and inspiring us all the way along.
Thus, we welcome you, sir, to take the session on AI is real, perspective on weak and strong AI.
Okay. Thank you. Thanks to both of you, Krishna and I don't remember. I don't see your name. Yeah. Okay.
Gifted, sir.
Yeah. Thank you very much. So shall we start?
Yeah, yes, sir.
Okay. Thank you.
Yes, sir.
So I just put my screen in full screen mode, so I may not be able to see any messages. So if you have any questions, feel free to stop me at any point in time, and then I may take up the questions throughout the session. So,
Sir, can we consider questions in the last of the session? Like each one of them will note down their questions and they'll be asking you in the last.
okay, no problem. Suppose if they are not able to understand anything in the middle, then the remaining stock should not be a discarded one. So that is the reason why I want this to be interactive mostly. Anyway, that's fine. Major questions we can take it at the end. In between, if they have some doubts, we can take it up in the middle.
Surely, sir.
Okay, so the talk is on AI. So AI is real. So most of the time, people used to see AI is something artificial, right? So people won't see that AI is real. When I was in Norway, I used to see one sticker. That sticker says, that was pasted on the main door of my group leader. So it says AI is real. So we had a lot of deliberations on it. So why AI is real? So we will continue. We will have some perspectives on it, and then we will also see what a strong AI system could do, what a weak AI system could do, and where are we now? So we will try to find the answers for many of these questions, and hopefully this will be this is a post-lunch session. Hopefully this would be enjoyable. Okay, so let's see. I just put the brief overview of my talk. One thing I put it here. Okay, what is AI? So do we really, there are many terms like learning to rank, learning to do a lot of things. Learning to is a very nice series. So learning to can be done for many specific tasks in several areas. In deep learning, you can see learning to classify. In unsupervised settings, you can see learning to cluster. Or in information retrieval, you can see learning to extract, learning to rank, learning to search. So all those things are learning to, right? So learning to code. So that is also one of the series we are following for our students. So this is actually a learning to think. So it's not for the humans, but for the machines which we are going to build, and the machines are going to, how do these machines think, are going to think themselves, right? So given the environment as well as the given settings. And also we will cover some of the basics of AI and logics, because I'm going to briefly touch upon all those things, because without that understanding, it is really difficult to see what a particular AI system could do and how AI system can be modeled, right? So that will be very much essential for knowing the perspectives of an AI system. So we will cover that, and then we will move on to certain few perspectives. I'm planning to cover some 8 perspectives in this area, and then I'm not going to like tell you each and every information to its depth, but at least I will cover you. I will tell you a very nice like input points to that. And also we will cover weak AI systems by and large. Strong AI systems, I will tell you what are all the open challenges in it. So why people are not able to come up with a strong AI systems that much faster, right? So 50 years back, we have seen a lot of like computing technology as well as computing power was very low. It was going up. It was theoretically like proposed, but nobody realized that those things will be coming in practice, right? After some 60, 70 years. So now people are realizing, okay, systems can do this. Earlier, we used to have a lot of newspapers. So I used to travel 5 kilometers every day to read newspapers. Now I am getting the newspaper on my mobile. Honestly speaking, I am not even reading one page, right? So this is in one way a benefit, in another way it is a disaster, right? So we will also see some of them, and some of the common challenges. In whenever we develop a system, we will have certain challenges. The challenges may not be talking about the technology itself, because technology is proven, and then people will worry about scaling it so that business can take it forward, and then people can make money out of it so that the business could survive. So, but some of the challenges in strong AI systems are completely not that much trivial. So we have to understand it from different perspectives. And then what would be the future of AI systems, right? Will it take our jobs out, or will it really like ensure that there will be a scope for learning AI, and also it will be the future of all our computing like minds, right? So okay, let's see some of them. Okay, what is AI? So you can see a lot of Google definitions. They used to say that, okay, they act like a human, right? So that is AI. And then, okay, can it think like a human? That is actually a question, right? Since it has, I give you 100 numbers, I ask you to sum all 100 numbers in 10 seconds. Can you do that? But the machine can do. For that, we don't need any thinking, right? One simple linear scan will achieve that result, but that is not going to be like problem that involves thinking, right? Simply you are going to write a like solution maybe in one line, and then the computer will repeatedly doing that, and then finally it will give you the output, right? So if I give you 10 random numbers very fast, and I don't know how many of you can give the answers very fast, right? So can we try that, all of you? Okay, I give you random numbers, 12, 54. I told you this is a random number. Okay, can you tell me the sum of these numbers? No, you don't need to unmute. You can see the chat box. You can type it in the chat box. I'm also keeping track of the chat box messages. Shobik Pailan, thanks for your message. You can also see the chat box messages. Okay, so you need a calculator. So you will take it 12 plus 13 plus 14 plus 52 plus 43 and so on and so forth. And then you will get an answer. You will tell that, right? These are all a few numbers. If I generate 10 million numbers in 1 minute, I can do it with my computer. So the problem is not that much difficult, right? So whatever I do the same for 10 numbers or even 5 numbers, I'm going to repeat, I'm going to extend the same solution for adding 1 million numbers, right? Only then the number size may be bigger. So you need to worry about the limitations of the particular primitive data type. That's the only problem in that, right? But do I learn anything from that? Is it different from adding 2 numbers? That is actually the question, right? So you take 12 and 13, whatever result comes up, and you are going to add that result with 14, and it is going to be the same. The process is going to be the same, right? There is nothing new is coming up. There is no need for thinking, right? But several problems are not of that type, right? So we need to think. So humans are capable of doing that. Sometimes we think it in a nice, wise way. Sometimes we say that we make some wrong decisions because our thinking was in a different line. After that, we say that that action is not giving the expected result. So we will learn from that failure. So that will lead to failure. We will learn from the failure. And next time, before making such kind of decision, we will think once. Okay, last time I did this. Suppose, for example, you are going to book a ticket. So you are going to the railway station. Nowadays, I think most of you are doing online. But assume that you are going to the railway station and you are going to book a ticket in a train for your festival. Maybe you plan to go to your home for your festivals. So you are booking the ticket. That call ticket is booking. That call ticket will be there for only 30 minutes or 40 minutes and or even 1 hour. So after that, it will be over, right? So what you will do? If you go late, you can find a big queue, the queue of 60, 70 members. So obviously you will not get a ticket. Next time, what you will do? Will you go by 7 o'clock or will you be there by 5 o'clock? It all depends, right? So now everything is digital. You don't need to move anywhere. At least next time you will be ready just 5 minutes before the Tatkal time starts, right? So you will be immediately logging in and then you will try to book the ticket, right? So this is actually the experience. Every episodic thing is an experience, and that helps the human to build his knowledge base, and that comes only through thinking and experiencing by themselves. So machines are supposed to experience by themselves, but how do we make the machines to experience it by themselves? So that is actually one of the things. Then it has to learn from that experience, and it has to encode the learned experience in terms of representations, and then those representations should be used for solving similar future problems. So what AI could do is, can we create a machine that can think like a human first, right? First, nowadays it is acting like a human, but can it think like a human? So that is the big difference. We will see how far we are moving in. Okay, just one second. Yes. Okay, so by definition, AI says, okay, once again. Okay, the definition of AI says simulation of human intelligence in machine. So we are going to just mimic the behavior of humans, and through certain programming, certain way of programming, and to make it to think like a human and mimic their actions. So this is actually a textbook type of definition, right? So, but the takeaway point here is machines are programmed, pre-programmed to think like humans, right? Whatever not programmed in that, whatever cases which are not considered during the programming, then the system cannot act in that place. If such events are occurring, then the like any robot or any other device you are creating with the AI techniques, then that will not respond. So the goals are basically, it's a generic goal. So learning, we made a system, just we are making a robot, and assume that the robot is supposed to learn by itself, just like you could have seen a lot of movies, Indian and Hollywood movies. They swap the book like here and there, and then it learns from the book, right? Maybe it is funny, but reality is, yeah, can it read by itself? So it has to understand, so the font size, and also it has to understand the natural language. It has to learn from it. It has to understand that, and then it has to represent it in its mind. And nobody knows how the information is stored in our brain, right? In a human brain, how do we store the information? So that is actually one of the open challenges. People are trying to find the way how it is encoded so that they can easily replicate, right? If they figure it out how it is encoded, then there will be a mechanism to replicate that. So that is actually one of the major tasks. And then we try to perform reasoning on the top of it, and then we try to take some sort of actions, and then based on certain perceptions. Okay. So we will see a few more. Okay. Let us consider this. This is a very nice game, learning colors. let us consider a kid below 5 years. So can you ask this question? So what is the color of the following objects? So this is the ball. What is the color? You just find a kid around you. So maybe in your living place or in your hometown, find a kid whose age is below 5. So and ask, okay, what is this? What is a color? Just ask this question. You show any object and then ask what is the color of this object. So look at this. What is the color of this? What is color here? So when you show the first one, then kid understands, okay, something round in shape is called color. We say that this is blue color. So it will learn the term blue. It will try to map with the object, try to find how to encode that blue with this RGB values, right? Basically, this is going to be some sort of values in RGB coordinates, or if you can take even in any other image coordinates. So for example, we consider RGB, then it will be composed of R means red, G means green, B means blue. It means blue gun will be on, red and green will be off. So it means that's why it is only blue. So obviously you will get 0, 0, 255, right? So obviously values are varying from 0 to 255 because it is following 256. So obviously 256, 256, 256 will get 16.8 million colors. So out of which blue is only one color. So you are going to say, okay, the color of the ball is blue, right? So object is ball. First ball, what is ball? It will understand, it has to understand. What is blue? It has to understand. So it has to understand shape is not blue, right? Something put on the top of the shape is blue. So it has to understand. Because when you show the second object, it will say that this is a square. First one is a sphere. We don't say it as a circle. It's a sphere, 3-dimensional. And then second one is a square. So 2-dimensional. So you can see how do we understand this is square is a different object, but the color looks similar, right? Or even same. So here, this is another one with a little bit light exposed on it. This is also similar to the ball, but it has no stripes on it. And then these are all several balls. We have different balls, red, yellow, like magenta, green, blue, all other different balls. Now it has to understand, okay, the color is not the one which is not in the shape, but it is on the coated version of that. So whatever is coated on the top of the object, that is called color, right? So what is that color? What is the name of that? We call it as blue or red or pink or whatever, right? So do we realize? So first time you say, it will not say the answer. Second time you repeatedly keep saying, then it will listen to what blue means. So it will be recorded in his or her brain, and then it will start responding to it. Something comes like a blue car, suddenly it will say blue, blue, right? So at that point, the kid starts understanding the difference between the object and the coating on the top of the object. So which is nothing but a color. Okay, so let us consider one more example. Okay, same question. Let us look into this. 5 members are playing. They are wearing different. Maybe you can see Rangoli time. They will have different colors. So here you can see 5 different ants, and then here 5 different like wax. This is actually a mix of all the colors. Now, if you show this to a kid, so how will a kid understand this is a blue color, right? So, or this is the red color. What is red? What is blue? What is green? So it has to distinguish. The moment you say this, suppose this is actually the green color, then it will say that, okay, wherever that color comes up, it will try to understand that that is green. So green is not the shape, but it is the color. Okay. So can we say that we achieved enough realization for understanding the colors, or even did we make enough realization on the kids to, or even to make them to understand the colors? That is actually a very interesting mechanism. You can experiment this with the kids around maybe around your hometown. But these are all called like something like what we perceive, what we learn, and what we realize, right? So that is actually the basis of applied intelligence. So what we perceive, That is actually intelligence. How we apply it on different things, that is going to be applied one. So what are all the facets of an AI application? What we do is we use sensors. It can be a visionary sensors, it can be sensory sensors, or it can be any of the acoustic panels or any other sensor devices. Through devices, we are trying to get the censored information. So using the data, now once whatever we get from the sensors, we are trying to get the stream of data. The data itself is not going to work, right? Unless we change it, unless we learn it. Here also data is there. In the previous one also we have seen data is there. So data is nothing but the color, right? This red, green, blue, right? But here red, green, blue is, okay, the boy is wearing the red shirt or even the red color, or wax is of red color, right? The painting has red color. So you can say that. But here, when it comes to only red, it doesn't make any sense, right? Or only blue, unless you apply it in a context, it will not make any sense. So now what we do is, whatever data we are collecting, we are trying to process the data. Suppose if it is a machine learning problem, we try to use it for prediction analytics, or even we try to use it for clustering, classification, and many more tasks. And if it is text to speech, we are trying to see how to do text to speech and vice versa, so that people can talk and that will be converted into text. That text can be easily interpreted. Okay. So similarly, text can be converted into speech. So someone will read the book for you, right? You don't need to even read the book. You just switch it on, like what we do with Kindle. So it will read the text and it will tell us. We just listen, right? Simple. So another one, vision. So whenever you are going through the toll gates, you can see a lot of cameras mounted on the top of the toll plaza. So just to monitor which are all the vehicles passing through, whether they are paying the toll price, everything, right? So you are having CCTV camera just to view who is coming, what people are doing, right? That is to one way security reason, another way just to know about the environment and the surroundings. Whether you can also see the cameras everywhere, in the factory, in the buses, everywhere, right? That is to not to take any personal information, but of course some unethical people can do. But honestly, what we do is we are trying to get the data and we are trying to perform different operations or different methods on it and to do particular tasks. If it is a face recognition, we are trying to use the faces, not the entire body, right? So like that. So we can go with a particular, if it is number plate recognition, the entire car is not required, just a number plate is sufficient. So the camera should be mounted in such a way that it can capture the number plate in a car. So it depends on the problem. You take your mobile phone and then call Google Assistants. Okay, just to say, call my dad, right? So if you have stored your dad's name, that name should be converted. Whatever you speak, that should be converted into the name. That has to go to the contact and it has to search for. If there is no match, it has to say there is no one is there with the name. Sometimes whatever you say may not be understood by the system, or it may not be exactly translated in the same way as you expect that system to do. So what we do is, their misclassification or process will start. So obviously your input will not be, the process will not be complete. So that will lead to errors, and then you need some sort of correction there. So if it is a natural language processing, you take any web data, so or you search for anything in Google, right? Google gives data for any queries, right? So that is your belief. I will also show some examples where Google will perform very well, and then you can also see the complexity of the search problem. I have 2-3 examples in that. You can also check those examples by yourself. So the problem here is the data is plenty, right? Almost like 40 petabytes of data is there on the web, that is in the unstructured format. Remember, that is very huge, right? So you can harness the power of this unstructured text data through data extraction, and then you have to translate them so that can be represented in a structured way, right? And then you can classify them so that you can say that this is a tourism data, this is the sports data, this is the health data, like that. You can do a lot of classification on the top of it depending on your application. And then what will happen? All these data will give you some sort of information, right? So it can help you to build your knowledge. So the more you build, the better your like decision making would be. So the expert systems are depending on such kind of data processing. And then for a completely unseen scenario, the expert systems will seek for the data, and then it will take the decisions based on the past history or based on the similar patterns encountered and the solutions proposed for such patterns. And then obviously planning and optimization is one of the main thing, because we have the computing resources. Even you can take cloud resources so that it will be really very huge computing power. But the problem is, for the same, I give you one problem, right? You tell me the complexity. So we have taken the numbers, we have summed up, right? So what could be the better strategy, right? Starting one number, adding the next number, adding the third number, adding the fourth number, and so on. This is one process, right? One particular linear, linear scan. I will say linear because you are going through the entire list of elements at least once. Each element is visited at least once. So obviously you are going to visit each element surely once, so that you can add them in the sum. Sum will give you the right answer. But can we do it? Can we speed up this? We are going to do the same process. It means we are going to visit each element at least once. But can we do the process even faster? What do we do? Instead of taking one element and adding it to the sum, you take two elements and add it to the sum. What are all the two elements? You take the first element or second element, or first element or middle element. Next time you will take second element and middle plus one, third element, middle plus two element, and so on and so forth. Otherwise, you can take the first element and the last element. You can combine every time. The left pointer can move towards right, right can move towards left. When they cross over, you have visited all the elements. So whatever time you are going to take the sum, now it is going to reduce by half, because you are going to do anyway the linear operation, but the running time will be reduced by and large. Right? That is actually the benefit in doing the optimization. Right? Once you can optimize the process, or you can optimize the complete execution mechanisms. So because in most of the time, you can see even in the search engine, so each search engine is supposed to give you the reply in 0.03 seconds, right? So 0.03 seconds is a response time. Remember, there will be no time for doing online computation once the query is given by the user. So if there are any online processes that needs to be done, the system has to do it offline, so that the search time will not be consumed for that. So there are many things. We will go on with that. We will see some of the examples. Okay. First, we understand what is a data and what is information. From there, we will see how do we represent knowledge. Right. So data is simply a collection of facts. It is raw, unorganized, unprocessed. If I tell you 10 numbers, you will not know what do you mean by these 10 numbers, right? But when I compile that, and then I'll tell you, okay, this is the context. Now you can interpret the numbers, then it will make some sense. So it will give you some sort of logical meaning. So data is simply a collection of facts. Information is how do we understand the facts in a given context. So we will see both. We will see one quick example. Look at this. I have given you some numbers, right? 80.32, 76.23, and so on and so forth. So there are three columns. First column is just a random number. Second column is the same order, but two numbers are highlighted. Third one is also given. We have the same list of numbers, but it is put in a different way. So can you see the difference between these three columns, these three tables, I can say? The first one is nothing. I don't know what do we mean by these numbers. But second one, I can surely make some sort of inference, right? The one, okay, the highlighted one can be minimum or maximum, right? So we will compare both the highlighted values. Okay, which one is minimum, which one is maximum, we can find it out. Let us move on to the third. Now, I don't need to go through all the elements. Go to the first element, take the maximum. Go to the last element, take the minimum, right? So now the given data is there. Even after the third pass, we will not know what do we mean by 91.54. What do these numbers refer to? That is actually the interesting part. It can be marks, it can be weights, it can be heights, or it can be any meaningful raw information, right? So let us look into this. Okay, let us look into the data. Now I am using the same number, but I am putting export item, the duration, then the turmeric is the name of the item to be exported, and these numbers are going to represent the amount of turmeric exported during this week in metric tons. Now it makes some sense, right? So now you can see, highlight this with a blue color, that is the minimum, red color, which is the maximum. So, and also you can map it. The first one corresponds to 13th, 14th, 15th, 16th, and 17th. So 5 days we have counted. So there are 5 rows. So each row is going to represent the average usage of a nuclei family in a particular city, maybe in milligrams, or it may be in grams. It can be anything, right? So that's why we put star here. So either it can be a metric ton or it can be in grams, right? So does it make this, does it make any sense now? The numbers are completely may not be meaningful unless we add them in a context, right? Similar to your grades. Your marks are meaningless until it is associated with a course. Then you can say that I have taken this many marks in this course. Otherwise, I say 95 marks. What do you mean by 95 marks? Right? You can say 95%. It means maybe you got 95% in a particular like grade, a particular program, like either even +2 or even SSLC or even your graduation or even during postgraduate. If I say 9.2 CGPA, okay, I can say that, okay, this is the overall cumulative performance of the guy, then that makes sense. If I say 9.2, it will not make any sense. Okay, so let us look into this. This is another example. Same number. I put the name and the number. Now you can see the number is associated with this name. But in what way it is associated, we will see. Okay, name, and this is the weight. Rogan is a fatty boy. Soumya is a maybe slim girl. And then you can also see here, I have added this name 2018 as on 25th December. Right? So obviously, there are some sort of colored names also. So now the name, the weight is sorted, and then Rogan as on 25th December 2018, his weight is 91.54 kilograms. Right? So Priya, this much. Rahul, the value is given. You can see there are 3 colors. What do you mean by these colors? That will give you additional information. What is Rogan, Rahul are all in the same color. Priya, Soumya are in same color. Lucky Vojal is in another color. So now you can associate red with a gender and blue with another gender, and like you can say brown with another gender. So you can make lot of senses. So data itself is not sufficient unless we have more features. The more the features we have, more the data we have, more the information we can process through it, right? So in modern days, maybe your property is not the real property. That for the big companies, which one is the more valuable thing? The data. User data. Okay. So more value, more money. More data, more value, more money. Okay. This is one more example. This is actually the steel plant related information that comes in the same way. The numbers are now associated with stock market, right? This is for a particular price during the particular week. This is for this across different steel companies, but the values are different on a particular day. So the numbers may be same, right? Numbers may be different, numbers may be anything. But unless they are associated with this particular context, maybe you will not have any meaningful inference from that. So now one more. This is actually look into this. So no free meals. How much time will you take to read this? Even a fast reader, you can complete it in 1 minute. transaction fee are not the same. So mostly the news article is going to talk about transaction fee. Let us look into this, right? No. So if I look into this paragraph, there is nothing colored. So I have to go through each and every part. The moment I color it, what happened? I don't need to go through all the black content. So all the characters highlighted with the red color, I can go through. Transaction fee, particular date. Okay, news was reported in Mumbai. So it was saying pay go with this much money, transaction fee, RuPay comes with this much transaction fee and all other things. Okay, other things are not useful for us, or we can only extract this information and then we can put it in the table, right? The entire paragraph, if you take to read 2 minutes or 3 minutes, depending on the speed of your reading. So here you don't need that. So we are extracting the information, we are putting it in the table. The table will tell you which one is the low cost, which one is the high cost. Simply you can go through the table. So it will take not more than 10 seconds to realize that. But in 10 seconds, you cannot read the paragraph or even any news. Okay. So can we understand this better? So this table is one. Can we understand this table even better? Let us look into this. This is the data we have collected from the paragraph, and then I put it in the graph. Now this is in Python, transaction fee. I can right away see which bar is lower, that is called RuPay. I don't even go through the numbers also. Here I have to go through the numbers since it is not sorted. So I have to go through each number from top to bottom. I have to find the minimum. So it is actually finding min and max here. But here I don't need to find min and max. I have to see the bar which is minimum and the bar which is maximum. So I can go from this x-axis and I will see which one crosses first. So that is the minimum. Which one crosses last is the maximum. So very simple. So this is actually a structured one. Previous one is completely in a formal language, right? So human can understand this faster, but how do we make the machines to understand this and then to generate this type of interpretable information? Okay. So visualization is one part in that, may not be necessary. So we are going to gain the knowledge from what we are reading, what we are perceiving, what we are realizing, right? So the question is, what is knowledge, right? It may be too philosophical, I can say that, because can you see the knowledge, right? So can you see, how will you test the knowledge, right? So whether the guy is knowledgeable or not, you talk to him, or you just pose a challenging problem, he will solve it, or you also see that whether he has any good solution for a given problem, then you can see that, okay, he has knowledge in that. If you take a rocket scientist and give him some other task, he may not be able to do, right? So you take a maybe pilot and then ask him to drive a car which he may not be able to drive. So then that will be completely a disconnected one, right? So he may have the knowledge to drive a flight. He may fly, but he may not drive. So that or the reverse. You can even take that the person who can drive, he cannot drive the flight. You need a special skill set for that. So knowledge is all about how do you gain that skill set in the particular domain. John knows that it can be anything, but John knows, right? John knows something that follows this dots. So that is actually what John knows. That is actually one of the knowledge, right? So it is going to be his knowledge. Okay, John knows that David will go to London this week. It means they would have interacted, or he may have come across some information about David, that David will not be there in the office. He will go to London this week, or even Mary will go to party today. So it is just maybe you would have talked with Mary, or someone, Mary's friend would have informed John. So that can be. So, but the ultimate thing is someone knows about the happenings, right? So what is happening? So knowledge is a relation between what I know and the proposition, right? Maybe I can express it as a declarative sentence. David will go to London is a declarative sentence. Mary will go to party, a declarative sentence. John knows that I'm not well. So the I'm not well is a declarative sentence, right? So when we combine this knower and the proposition, you can even say that whether it can be true or false. It can be, propositions can be truly abstract. So, but when we look into the propositions, it can be either true or false. I am not well, that is true. I am not well, maybe false, right? So it can be in either way. David will go to London this week, maybe true if David really goes to London, right? So if David is not going, then maybe this declarative statement would be false, because the event will happen in future. If David goes to London, then it will be true, otherwise it will be false. So declarative statement can be true or false. Okay, but whatever it comes up, John knows that, right? John knows that he will go to London. It means it is, if he goes to London, it is true, then John knows that, then it will return. If David is not going to London, then also John knows, okay, then it can be again true. Sometimes he may not know that David did not go. That can also happen. So now the possibilities are enumerated, right? Look at that. There are two propositions. John knows is one proposition. David will go to London is another proposition. These two propositions you can enumerate, right? So you will get 2 power 2 possibilities. Okay. So let us move on to how do we represent that, right? So the first one, we can take the relationship between two domains, right? So first domain is the representer, and then like John knows like this. Second one is abstract. So we are going to make a relation between these two, right? So we will see how do we do that. Okay. How do we represent the knowledge? It's very straightforward. We use the formal symbols, and then the formal symbols will be used for representing the collection of propositions. We believe that the propositions can be either true or false. It cannot take maybe, right? It is either or, binary, right? So it will take either true or false. Okay. So what is the gap? The role of reasoning. So there we have to reason the gap between what is represented and what is believed. Believed is represented by the proposition, and represented is like the knowledge of the present. Okay. Okay, we perform reasoning. So reasoning is needed for doing such kind of representations, such kind of like inference. So how do we manipulate? How do we do reasoning? We take the symbols, try to manipulate. Instead of saying John goes to London, true or false, we will say, okay, X equal to John goes to London. If X equal to true, it means John goes. If X equal to false, John does not, or John will not. So like that. So we are going to take that entire formal thing into like symbols, and then the symbols are representing the collection of believed propositions, right? So basically we believe it, that may be true or that may be false. Sometimes we believe the true things, sometimes we believe false things. So, but that will produce new representations, and then the decisions could be made on that representations. Okay. So let us see some more. Okay. Let us look into this reasoning part, right? So, okay. Can you tell me the answer? You can type it in the chat box. The first one you can see, second one, third, fourth, fifth, sixth, seventh, eighth. You have to predict what would be the ninth box. I have given you 4 answers, right? Look at this. Square followed by the arrow, and then it moves one step. Square followed by the arrow, and then it makes a cyclic thing, right? And then it moves to the next line, and then it does the same thing. The arrow moves in the same row, and then square moves in the same row, right? This is the first row, this is the middle row, this is the third row. So there are 3 rows. So square and arrow moves in the same way. Okay, C, good. Lot of people, great. Great, C. So C is correct. Why? Because look at this. This is actually in position 1, then this is in position 2. Obviously the box, square box will be in position 3. So here this is in position 2, 1. So we can say that we start with 0, 0, 1, 2, again 0, 1, 2, like this. Here 0, 1, 2. So obviously the square box will come in 2th position. This arrow will come in 0th position. This is basically K mod 3. So that is actually the thing. When you take K mod 3, so you can even know the positions of the arrows. Okay. So Answer 3 is the right answer. Very good. Now let us look into the analogy. So how did you achieve that? D is not the right answer. C is the answer. Most of you gave the C answer. How did you reach that analogy? Basically, you arrived at a decision, right? Basically, you said that C is the right answer. How did you arrive at? So you have, before arriving at the solution, wait, okay. Before arriving at the solution, we try to gather the information here, right? Okay. Can you say the behavior of the square box and the behavior of the arrow? We try to get something here. We try to apply it here and check whether it is correct. If this is knowing, this is verifying, this is applying, predicting, right? So learning and then like representing and then realizing, right? And then applying it. So it comes like what you learn, what you perceive, and what you apply to predict. Learn, perceive, predict. Those three are the lines you can take it from this analogy. So now we can see this is the number 1011 and then 10 implies 1101. So what will you understand from this? If you add this, what you can do is and is coming up. Can we add these things or multiply these things or even subtract these things? Will you get this? If you add and get this, then it will be simple binary addition. Otherwise, if you multiply this and if you get this answer, then it is basically a multiplication and so on and so forth. So basically what we do is we are trying to know, we are trying to learn from this what type of manipulation is done here, either addition or subtraction or multiplication or something similar to it. Now look into this. I think there is a problem with the system. Timing issues. Okay. Yes. Okay. So now look into the similarity. John loves Mary, and Mary is coming to the party. So Mary is coming to the party is a predicate. John loves Mary is another predicate, right? It means you can see this Mary and this Mary may not be the same. Remember, this Mary is someone, this may be someone else. So, but when we map it together, if this Mary is the same Mary, then we can say someone John loves is coming to the party. We don't need to even know about the particular person. Someone John loves, that is the person. That can be Mary, or it can be Stella, or it can be any other name, right? So is coming to the party. So we are trying to infer this information. This is the analogy. Basically, we are trying to get it. Here, the addition is the analogy. We are trying to see, okay, if you take these two binary representations, if you arrive at the third one by means of like bitwise addition, you will get this. So that is the analogy. So we can have different types of analogies. You can have picture analogy, shape analogy, you can have number analogy. Suppose if I give you 1, 2, 3, 4, that gives you 4, 3, 2, 1. Then how will A, B, C, D will give, right? So that is actually the number analogy, right? So, okay, we will go on to that. That will come in the next few slides. Okay. Now we will see how do we come up with a logic representation. Logics can be represented in multiple ways. The simplest form is propositional logic, and then slightly improved version, first order logic. And then when you include time related information, you can go with the temporal logic. And there are a variety of extensions to these logics. And then higher order like representations can also be seen. But why do we need this logic? Why do we need these representations, right? We will see why do we need in the subsequent slides. So logic defines sentences formed in a language. How do we form a sentence? How do we represent anything? Suppose someone is saying the color of this car is red. How will you represent it? Human can understand, okay, car is the vehicle, four-wheeler, and the color is red. Okay, so, or even Ford color is red. You can say that, okay, Ford is a car whose color is red and other things, right? So simply, how will you represent that? So that is one thing. And then there are some sentences which we are representing through syntax. And what are all the semantics of it? What type of meaning we can infer from those representations? We will go through that. Propositional is a very simplest form of logic, right? It is raining outside and traffic in Oakland is heavy. You can divide into two parts. One is you can take the first one, raining outside can be true or false, and then traffic in Oakland is heavy, that can be true or false. If both are true, that's why we are using join operation. Meet means meet and join, right? So join means this, and this is actually a meet operation. So it means this has to be true, this has to be true. So both should be true means then it will return true. It is going to be a truth table. This you can take it as A, this you can take it as B. Now A and B. So A meet B. So A meet is a and, join means union, right? So you will go, so we are not going to use join here, we are going to use meet. So both should be true. So this is actually one complex sentence. We have to divide that into atomic sentences, and then we can represent them. And then when we represent through formal symbols, then the reasoning becomes even easier. So now it becomes A and B. Both are giving whether the outcome is true or false. If it is true, yes, it is raining outside and traffic is also heavy. If it is false, yeah, it is raining outside, but traffic may not be heavy. Or traffic is heavy, it may not rain, right? So it can go in either way. Okay. Okay, let us not, I told about the car color, right? So car 12. 12 is the identity of the color. There can be 1, 2, 3, 4 like that. You can number the car based on the parkings. So the car parked at slot number 12, so is of red color. So basically car, ruby red, and then the number. Then the car is of ruby red color and the registration number is this, right? And then brother of Peter, John. John is the Peter of brother, or Peter is the brother of John. You can, it's all about how you define brother, right? So parent means like parent X, Y. So X is a parent of Y, right? So our Y is a child of X, right? You can even say that. That's why this one is, this one parent of X, Y will give you child of Y, X, right? Brother of Peter, John will also give brother of John, Peter, right? Younger brother or elder brother, you can even say that, right? Okay. So how do we represent car number 12 is red? So we have given here this one. How do we represent in a logic, right? So that we can make the inference easier. We will see that different ways of doing, right? So this is one way, red of car 12, which we have seen already. So red is a color of given object. Car 12 is an object, right? Car parked in slot number 12, that we can infer in that. And it is easy to, what is red? Again, the same problem, learning colors, right? So we cannot ask what is the color of car 12. So can we ask what is the color of car 12 here? Why can't we ask? Unless we know what is red, we cannot ask this question, right? So we should know what is red. If color of red, right, car, 12, red, then you can even see that color of car, red. Now you can see color is the property, car is the object, and then red is the value, right? So you can see object and then property and then value. So attribute values can be car 12 and red, and color can be the property, right? So you can even mix and match it in different ways. So now it is easy to ask what is red. Yes, red is a color. So now it is easy to ask what is the color of car 12. Yes, it is red. So now can we ask this? What property of car 12 has value red? Because that is the that is actually the color is going to be the property, right? So unless we know what is mean by color, color is a property. If we know that, then we can answer this question. Otherwise, we cannot ask that question. So now, how do we change the solution? Property of car, color, red. It means property of the car 12 is one of the properties of the car 12. We can say one of the properties of car 12 is color and its value is red. So car 12 can have multiple properties, right? Multiple attribute values, right? So each car may have multiple attribute values. So for example, you can say the seat capacity, or even the fuel capacity, or even you can say, okay, what is the model, what is the engine size, what is the like infotainment system, what is actually, what are all the benefits, what is it, a manual or automatic transmission, all those things you can put for a particular car. So everything will belong to a particular car, 12, and then attribute values will keep changing. Remember, attribute is always unique, values can be multiple, right? How many doors are there? 4 doors. So door is 1, but left door, right door, front door, like that, all right? So that is going to be back door, left, right, back, something like that. So you can add all those things, but that is going to happen for a particular attribute. Values can be multiple, attribute will be only one, and the object can be a specific object, right? So keep that in mind. So to understand the ways of one small object and its property, we need to encode a lot of things so that system can understand all these things in its own way. Human can understand color of the car, 12 is red. This line is sufficient. He knows what is car, what is number 12, what is red. All those things are already known, encoded in the brain of the human system, right? But here for a computer or even a machine, it may not know what is car 12, what is color, what is red, unless we specify this. Okay, property, object, attribute, value. So it may not know the answers. Okay. Now when we call it as property, object, attribute, value. So you can say, we will say property, you just put this as attribute 1, attribute 2, attribute n, attribute and values. So basically we are trying to get the frames, and then frames are just like, it has 3 dashes. In the first dash we will see the name of the object, car 12 is the object, and property 1 is attribute, property 2 is the value. Sorry, I'm not able to see the, okay. Okay. Let us look into this example. Okay, distance between Bucharest to Bucharest. What is the distance between Bucharest to Bucharest? What is the distance between Delhi to Delhi? 0, 1. Yes, you try it in Google Maps. Bucharest to Bucharest, it will say 0, right? It will say you cannot have the same starting and ending point, right? But the moment you put any one of the places here, right? Here you can see Park Lake, and also you can Uber. So it will show you the distance, right? So it means these two are the places, and the value will be the distance between them, right? And also it will show you the path, right? So it is actually very simplest form. This is another example where you can see Clyde is an elephant. Elephant is gray. So actually it has to be Grey. Gray. Okay, sorry for the spelling mistake. Yeah. So gray is the color of an elephant, and the Clyde is the name of the elephant, right? So can we do? Okay, why it is not coming up? Okay. Now look into the same example I have taken, gray, elephant, Clyde. But we cannot say gray cannot be associated with the Clyde. So you can say Clyde is an elephant is gray, but Clyde is not gray, right? It means these two are not the same. This elephant and this elephant are not representing the same like object, right? So, or entity, you can say. So entity can be a living entity or even immobile entity. So you can even say this elephant and this elephant represent two different things. Then this cannot be mapped. So that is actually the uncertainty in reasoning. Unless we know that Clyde is an elephant and we are also talking about the same elephant and its color. So then only we can say this one, right? Clyde is gray. Otherwise, Clyde will not be gray, or gray is not associated with Clyde. Okay, so another one is common sense reason, right? So you can see the World Wide Web, very huge collection of documents. What you can do is, okay, a pen can fit in the box, or box can fit in the pen. Or what is the challenge here? Pen can fit in the box is a common sense, right? So box is something like in a square or rectangle shaped or even a circular shape. So we are putting the pen inside, so it can hold. But pen cannot hold the box, right? So that's very common sense in that, because pen size will be very thin and box will not be in that way, right? Unless we come up with such a box, we cannot go with the inference. Okay. Okay, so I don't know how much time is left over. So I can take 20 more minutes, right? Dr.Rajendra or someone?
Yeah, sir. Actually, it's 2 to 3 only.
2 to 3 or 2 to 3:30?
So
Okay.
actually, it was planned 2 to 3, sir. So we can take some questions from the audience.
Okay.
Okay. So if anyone have some questions, so please ask through chat.
We are going to discuss the equation. Now, let us see. If your rotating body displays the equal angle in equal intervals of time,
Sorry, I am not able to hear.
then it is known as uniform angular
Just a second, sir.
The uniform angular that means the omega is.
Well, you can check with the chat box for.
Yeah.
Yes, sir. We are checking. Actually, there is lots of noise from the end of you. So we are
Yes.
checking in the chat box. So anyone, if you are having some question, please do it. Yes, sir. So we have a question here, sir, from Agis. He's saying that, can you please elaborate on how you used information retrieval and artificial intelligence to handle textual content, especially scientific articles, and to perform scientific knowledge discovery during your research work at NTNU?
Okay, very nice. So I will show you one graph, right? So that you will understand that one. Okay, 1 second. I'm just getting that. Argish, right? That's the name. This is actually, you can see my screen, I think. This is actually the called multi-stressor experiment. So what we do, we are taking the scientific articles. Basically, we have collected 700,000 abstracts of the scientific articles that belong to climate change and global warming related or even environmental related research papers. So 700,000 is too big. So we have taken the data, and then what we did is we tried to do, these are all the information. How many like article abstracts I have taken from each journals. This is actually the publisher. From Springer, I have taken 18 journals, this many articles. So what we did is we created a graph like this, right? This is basically a text mining. So we applied information retrieval by and large to collect the data. Basically, we did crawling, and then we extracted the information. That is actually part of information extraction. We had different types of wrappers. And then in each of the scientific articles, we tried to find out the entities, right? This is actually the entity recognitions. So once the entities are there, how will we come up with the relations? For that, I cannot do simply a graph-based data processing. I need AI to know their interactions, because here iron can interact with the CO2, and then algae can interact with CO2 can interact with algae. It means the more the depletion of iron may help the algae to grow, the algae will take more CO2 from the atmosphere, so that algae can grow very well. So that CO2 emission will be reduced. So this is a basic experiment done in that. So can we identify similar such entities and their relationships? So we defined a lot of other relationships, and then after the experiment, we have identified that, okay, nanoplankton is making a huge impact on algae. Iron is making a huge impact on CO2, like this. So this is actually what we try to explore from the scientific articles, because one researcher cannot go through 700,000 articles, right? It will take hell of time. But the moment you get this data, so each node is connected with a set of articles. You click on that, you will right away get a subset of articles. Maybe that subset will have 20 or 30 or 50 articles, which a human can easily go through. So for that, we need AI. So we applied it, and then we got this. Is it okay? Does it answer your question?
Okay.
Yeah.
Yeah,
Another
sir.
one?
Thank you, sir. So we
Can
have
you
a question here. Yeah, we have a
I
question
will read.
that
I will
it
read.
is. Yeah, okay, okay.
Can you share what observations and factors motivated you to work upon knowledge exploration, and why is more important? Okay. So actually, I have gone through halfway my slides anyway. That is okay. See, knowledge exploration, right? Human knowledge is very hard to capture, right? So can you mimic all your behaviors, all your actions, the way you understand the things? Can you like convert into a program easily? That is actually the major challenge. So if you can do that, obviously you can do everything. You can recreate a human, but that human is an artificial robot or any other humanoid robot, but it will mimic the same mechanism. It will also have the same feelings like as of human. So what we do is this exploration. For example, if I give you captcha, right? So how will you know that okay, can you write a program to overcome the captcha? You don't want to enter the data by human, so you create a robot or even a program that can take the input from the captcha, and it will give the right text message or even the like clicks for the corresponding image or images given in the captcha. So that is a harder problem, right? So that is actually not a weak AI problem. It is a very strong AI problem. So we have to work on that. So that is actually the way. Even if we make small changes in the like way how we explore the information, that can maybe unleash a lot of other hidden things in the computing domain. Okay, another one as business intelligence modeling is your area of interest. No, that is one of the areas I worked in that. So my primary area is distributed algorithms and information retrieval. Okay, could you please highlight how it is powerful strategy tool, how you enter data? Okay, for that I need to, okay, I can show you one more. Okay. You need to go through explore my desk. So, okay. You're not asking questions from, look at this. This is actually the business model, right? So how do we come up with a business model, right? So this is the most important thing, because business model is going to tell you what are all the key activities done by the company, what are all the value propositions, what are all the relationships, and how do we make cost and revenue, right? If you, whatever cost you spend to create that product, if it is lesser than the revenue, you will have the profit, otherwise you will have the loss. So before coming up with a product, you can come up with the model. If the model is convincing, then you can go for production. So obviously, you can also see how different companies are making money, right? So we created this product. This product is called B Media. It is actually business intelligence modeling. We applied AI powered system to read and understand the financial documents, and then find out the payment fee, processing fee of each mobile payment mechanisms, right? We have investigated around 265 products, and then we came up with their revenue streams, and then you can even see the market values, market trends, and then customer feedback and everything. You can even see the entire product is was alive. It was even traded for a good price. We did not sell it. We are developing the advanced version of the same. Okay, so this is actually the most important thing. If you are not coming to define your own idea through a business model, your business model, your idea will not elevate. Okay, you need, for this product, we have used knowledge mind, like knowledge based system, decision support systems, AI, machine learning, and then information retrieval and distributed data processing. So we have used techniques from all these 5-6 domains. If you know that how many memory storage will lead to great development. How are we? Okay, so yes, the issue is it's not about the availability of the computing resources, right? I think Arya's question is a good question. So it's not about the computing power. You can take the cloud service now, you pay for that, whatever you are using. You can use unlimited resources, right? So at least the resources which may be sufficient for your process, right? So, but if you take a problem, right? So even you take a chess program, how many moves are there? Can you enumerate all the moves? And can you come up with a solution in 5 seconds? Because in the chess program, the timings are 30 seconds, right? So after 1 hour. So every 30 seconds, you have to make the move, right? So can you come up with all the possible combinations, all the computations that should be over in 30 seconds? And it should say that, okay, this is the move you have to make now. Can you come up with that? That is actually the hardest part in that. Okay, it's not about the availability of the resources. It's all about how do we apply the approaches so as to achieve that in short span of time. Okay.
Okay, sir. So I guess like we are done with the question.
Okay.
That
I
was a
think,
great session, sir.
Yeah.
Being AI.
Lot of
Yeah, yes.
Krishna, one thing I would like to complete. Yeah. So
Yes.
a lot of slides I did not complete because of limitations. So I think 35 slides or more. I will share the entire slides. You can make use of. Yeah.
Okay, no problem, sir. It will be grateful. So, being an AI student, the first topic we studied was the classification of AI, but knowledge gained through experience dominates over books. Thus, we appreciate the time you took to explain us the topics such as this. Indeed, thank you, sir. So, I would like to call our faculty coordinator, Dr. Saundarajan, sir, to give a vote of thanks.
Yeah, yes, Om. Audible?
Yeah, audible, sir.
Yes, sir. First of all, I thank Dr. Rajendra Prasath, sir, for accepting the invitation for our AI Conclave 2021. I thank sir for giving a wonderful presentation for this session. So we people are enlightened about what is AI and all the essence of AI. So what AI will be given a instance of complete entire life of human and as well as for an industry people. So I thank sir for giving a beautiful explanation for all the topics, whichever they covered. And then the busy schedule, sir is given as for timing 1 hour 15 minutes. He given a presentation for all of people to understand about artificial intelligence importance uh, in India. So I thank you, sir, and I thank all the coordinators of this event, Om Krishna Yadav and Yukti Abir, and who other people are working in AI Conclave 2021. So I thank all. So once again, thank you, Rajendra sir, for giving a good presentation. Thank you, sir.
Yes. Thank you, Sundarajan. Thank you so much.
Thank you, sir. So we will actually he's a main act as a coordinator for our board of studies also. So I thank for that. Last board of studies, sir is given more input of how to design and vetting cutting of curriculum of BTech, CSE, AI and ML. So I thank you for that also, sir.
Thank you very much. Yeah. So I have not completed the entire presentation, so I will send that like set of slides, Sundarajan. You may share with the participants so that they can also learn from that.
Yes, sir, definitely, sir, sure.
Yeah. Thank you.
Thank you, sir. Thank you, sir.
Thank you so much, sir.
Thank you, Krishna. Thank you so much. So I'm